Continuing with section 1.8, looking at example 7 now. So we have a transformation from R3 to R3 defined by like this. T of x1, x2, x3 is equal to x1, x2, negative x3. Show that T is linear. Again, remember we can show it by 3 methods, but I will use the E1, E2, E3 vectors to find the standard matrix. So now E1, remember, is going to be the vector with coordinates 1, 0, 0. So we can write as T of E1 so T of E1 is equal to T of 1, 0, 0. So this will give me 1, 0, 0 because x1 is x1, x2 is x2, and x3 is replaced by negative x3, but x3 is 0 here, so negative 0 is T of E2. So this is the vector 1, 0, 0. T of E2 means T of 0, 1, 0, which will be according to the transform defined 0, 1, 0. So we get 0, 1, 0. And then T of E3 is T of 0, 0, 1 will be 0, 0, negative 1. So the vector 0, 0, negative. So now we say that A is equal to 1, 0, 0, 0, 1, 0, and 0, 0, negative 1 is the matrix. And you can check. So this is our standard matrix. We want to check that A times X does give us the output we have for the T. So check for any vector X with coordinates x1, x2, x3, Ax is equal to 1, 0, 0, 0, 1, 0, 0, 0, negative 1 times x1, x2, x3, and when we multiply the first row with the first column gives us x1, second row with the second column, well there is no second column, only one column, so second row in the first column gives us x2, and then third row with the column is negative x3, which is the same that we have up there. So hence, since we can write, or we have T of x is equal to Ax, therefore T is linear. Next one, example, let T be a transformation from Rn to Rm, be a linear transformation, and let V1, V2, V3 be a set of linearly dependent in Rn. So we have 3 vectors in Rn, and they are linearly dependent, not independent but dependent in Rn. Explain why the set TV1, TV2, and TV3 between the images of these 3 vectors. Why is this also a linearly dependent set? So we will try to show or prove this. So we start with this with this statement or with this information that the set v1, v2, v3 is linearly dependent. So what does that mean? One of the reasons or one of the conclusion of being dependent is that one of the vectors can be written as a linear combination of the other vectors. So I will start with since v1, v2, v3 let me not write the set notation. Since v1, v2, v3 are or form a linearly independent set, form a linearly dependent set, so set one of the vectors, say v3, we can pick any, it doesn't matter, can be written as a linear combination of the other two. So let this be the linear combination. So let us say that v3 equals c1 v1 plus c2 v2, where c1 c2 are scalars. Rewrite this. Where c1 c2 scalars. So now I try to find T of v3. So T of v3 will be equal to T of c1 v1 plus c2 v2. But because T is linear, I can say this is equal to c1 t v1, T of v1 plus c2 T of v2. Why? Because T is linear. But what is this? This shows that v3, T of v3 can be written as a linear combination of the vectors T of v1 and T of v2. Hence, the set t of v1 comma t of v2 comma t of v3 is linearly dependent. So that's the end of section 158.